slammer of the night, who is Sebastian Markert. He's a postdoc at Johns Hopkins, and he's going to talk to us to what happens when you close your eyes. I'm very curious about this slam. Sebastian, the floor is yours.
Thank you. All right. To start with, please do me a favor and close your eyes for a second. Okay, and open. So tell me what just happened. And I tell you, no one knows. Now you think, what? The answer seems so obvious, right? It gets dark. But darkness is a subjective experience that you have in your brain, right? It's actually based on what's happening in your eyes. So let me show you what's happening there. It's pretty straightforward. So it's pretty much this. In your eye, we have the photoreceptors, and they perceive the light, and they form these so-called ribbon synapses, where, pretty much this happens. They have these vesicles with signal molecule, and they put out signal molecules bit by bit, spoonful by spoonful. And so let's call these signal molecules water for now. So if they're putting out water all the time, the other cells perceive pretty much raining. So it's kind of like the other cells are holding out their hands and are like, oh yeah, it's raining. And so they report to the brain that this photoreceptor is in bright light. All right, so that's how that works. So now what happens when it's dark? What happens then? Well, actually the same thing, just much faster. Okay, it's dark now, please hurry, as fast as you can. So this might be unexpected, but this is how evolution decided to encode light and darkness, just by different levels of rain. Okay, thank you. So it really is the case that when it's bright light, there's little rain, and the darker it gets, the more rain there is. And in absolute darkness, there's maximum rain. All right, so that's how that works. But of course, the question was, what happens when you close your eyes? Or in other words, what happens in that time interval at the transition from light to darkness, right when you close your eyes? Because it's mysterious, because when we can measure actually the water output, and we find this. There's this gigantic splash, a flood, right? Very brief, but there's like a huge splash of water. We're not even sure what that is good for. It's probably really, so the brain really gets the memo like, hey, it's dark now, right? Like it's really like a kapow, not like a gradual increase in rain, but the brain really realizes immediately that now it's dark. Okay, but the problem is we don't understand how this splash is possible. This splash defies the laws of physics, at least as we understand it. Because, well, think about it. I've shown you, right, in darkness, the output of the water is already at maximum capacity. It cannot go any faster if you do the math. It's physically impossible, or should be, right? Like instead of 1 spoon, maybe I can use 2 spoons and do it as fast as I can, but then that's it. I only have 2 hands, so I cannot go any faster than this. So something weird must be going on here, something unexpected, something new. And scientists have been trying to figure out what that is for many decades now, but without success, because this splash is just so brief, you cannot catch it with an electron microscope. You would literally have to stop time right then and there to figure out what's going on. And of course, stopping time is impossible. Or is it? Sometimes you find inspiration in the most unexpected of places. Well, maybe I cannot stop time, but I can freeze stuff. If you freeze something, it stops moving. It's almost as good. So that's what I did. Maybe not quite like that, but with fancy equipment. So my lab has a high pressure freezer. Costs almost $500,000. But the point is, this machine can freeze with millisecond precision. That's exactly what I need. So in this case, I use zebrafish. Right, and then I did the regime, light is on. I switched off the light, that triggered the splash, and then I froze it right when it's happening. And then I used an electron microscope to look at the ribbon synapse to figure out what's going on there. And I'm happy to report, I think I know now. I think I figured it out, what happens when you close your eyes, when it gets dark. So attention, I'm switching off the light now, and then you will see. Do you see that? So something happens that we have never observed at any synapse ever. The vesicles these little spoons, they fuse with each other to form like a super vesicle and then release a huge amount of signal molecule water all at once. Yeah, so that's what's happening when you close your eyes. And it's so obvious in hindsight, right? Because what do you do if you want to have a big amount of water all at once? Well, you take a bigger spoon. So think about that next time you blink. All right, I'm going to dry off now. Thank you.